Hi, Algebra 1, and today we are going to look at another factoring strategy from Section 7.5, Special Products. Let's review our factoring strategies that we've looked at so far. Remember that we are always going to look for a greatest common factor first. If a polynomial has 4 or more terms, we are going to try to factor by grouping. If a polynomial has 3 terms, maybe you want to guess and check. Or last video, we learned about the difference of two squares, the DOTS. It's very obvious as long as you know your perfect squares. Today, we're going to learn about the PST, the perfect square trinomial. So, PS, perfect square. Same information we saw in the last video regarding perfect squares, and we see it again here. 1 squared is 1. 5a quantity squared is 25a squared. 6xy quantity squared is 6 squared is 36, x squared, y squared. So, perfect square. A perfect square trinomial is going to have a perfect square on the front end and the back end. And it will be a trinomial, which means it will have 3 terms. Then the last one must be positive. Actually, the first and the last one must be positive. So, perfect square trinomial. What makes a perfect square trinomial? So, let's start this lesson with this warm-up. So, pause the video here and complete the warm-up. So let's check number 1. Number 1, we're making a perfect square trinomial. And in order to make a perfect square trinomial, we have to square a binomial. And when we square a binomial using the FOIL method, let's look at what we get. X times x is x squared. X times 4 plus 4x. 4 times x plus 4x. 4 times 4 plus 16. Notice what we're getting here. We have a positive perfect square on the front and a positive perfect square on the back. And these two middle terms are always going to get doubled. So 4x plus 4x, or 4x times 2, is 8x. So x squared plus 8x plus 16. And that is a perfect square trinomial. So that's number 1 from the warm-up. Let's look at number 2. Number 2, 3x minus 2 times 3x minus 2. Again, in order to get a perfect square trinomial, you have to square a binomial. So 3x minus 2 times 3x minus 2 is 9x squared. Outsides minus 6x. Insides another minus 6x. Last sides plus 4. Once again, that middle term is getting doubled. So when we combine like terms, we end up with 9x squared minus 12x plus 4, which is a perfect square trinomial. Number 3. Notice that we can also write 5x plus 6 quantity squared. We can write it using the exponent. It means exactly the same thing as 5x plus 6 times 5x plus 6. And you have to use the FOIL method in order to simplify this. So first sides, outsides, insides, and last sides. And once again, that middle term does get doubled. So 25x squared plus 60x plus 36, and that is a perfect square trinomial. When you square a binomial, you get a perfect square trinomial. So, 2 more problems on the warm-up. They're a little bit more exciting with exponents that we need to deal with. So, once again, if we write the exponent 2, it means the same thing as 7m squared minus 2n cubed times 7m squared minus 2n cubed. It's the same binomial repeating itself being multiplied together. Use the FOIL method in order to simplify. 7m squared times 7m squared is 49m to the fourth. 7m squared times negative 2n cubed is negative 14m squared n cubed. Insides, negative 2n cubed times 7m squared is negative 14m squared n cubed. Notice on both the outers and the inners, we do not add the exponents together. We only add the exponents when we're multiplying and the bases are the same, like the last sides. Negative 2n cubed times negative 2n cubed is plus 4n to the sixth. Once again, the like terms in the middle, they basically double, and we are adding, so when we're adding, exponents stay the same. Negative 14m squared n cubed doubled is negative 28m squared n cubed plus the 4n to the sixth. And once again, we have created a perfect square trinomial. Last warm-up problem, similar problem. Remember, write it twice and use the FOIL technique in order to simplify to get this perfect square trinomial. So 8pq squared times 8pq squared is 64p squared q to the fourth. Add those exponents together. P times p is p squared, q squared times q squared is q to the fourth. Outsides, 8 times 9, negative 72p q squared r to the fifth. And again, another one, negative 72p q squared r to the fifth. Then finally, negative 9r to the fifth times negative 9r to the fifth is plus 81r to the 10th. Once again, like terms in the middle, they're just doubling. So we end up with 64 p squared q to the fourth minus 72 minus 72 minus 144. Remember, I'm adding, so the exponents do not change when you add. P q squared r to the fifth plus 81r to the 10th. So let's talk about the characteristics of a perfect square trinomial, and then we're going to start breaking them down. So here is one, 3x minus 2 times 3x minus 2. Remember, first sides, 9x squared, outsides, negative 6, insides, negative 6, last sides, plus 4. The first term is always a positive perfect square. The second term is what? Well, let's think about it. If it's always going to get doubled, it always has to be even. It has to be an even number, and it can be positive or negative. But the third term is just like the first term. It must be a positive perfect square. So those are some characteristics of a perfect square trinomial. Obviously, it has to have three terms because it's a trinomial. First term's positive perfect square, third term's positive perfect square. The second term has to be even. Now let's look at that middle term, that second term, a little bit more in depth. So here's the same trinomial again. 9x squared minus 12x squared plus 4. Let's look at 9x squared and let's think about its square root. The square root of 9 is 3. The square root of x squared is x. Okay? The square root of 4 is 2. So when we take that 3x and we take that 2 and multiply it together, we get 6x. Then we double it, we get 12x, which is the middle term. And if that middle term is negative, just think about how both of these, or really I should say, that is going to be negative. That -2 up front is negative. So that's where the middle term is coming from. So thinking on that, let's factor these three perfect square trinomials. So we're going to be thinking about, first of all, do we have a positive perfect square first term? Yes, 9x squared, that's the one we just had. It is a positive perfect square. So let's look at its square root. The square root of 9x squared is 3x. And then the third term, the square root of 100 is 10. So we've got 3x and we've got 10. What do we get if we multiply them together? If we multiply them together, we get 30x. But what is that middle term supposed to be? Is it supposed to be 30x? I think if it were a perfect square trinomial, it wouldn't be 30x, it would be what? It would be 60x. So maybe we need to rewrite this perfect square trinomial. Maybe it's not a perfect square trinomial because it doesn't meet the characteristics. So if it were a perfect square trinomial, it would be 9x squared plus 60x plus 100. So let's try it again. Glad I made that mistake. So here we go. The square root of 9x squared is 3x. The square root of 100 is 10. So plus plus, which is going to mean plus plus in the factors. We learned that in our guess and check video. So 3x plus 10 times 3x plus 10. Let's do FOIL and let's see if we get the perfect square trinomial 9x squared plus 60x plus 100. So first sides, outsides, insides, and last sides. Yes, there's our 60x. So our factors are 3x plus 10 times 3x plus 10. Of course, remember, you can write that as 3x plus 10 quantity squared. So this is a perfect square trinomial, but essentially we're factoring it using the guess and check method. We're making our very educated guess based on understanding the characteristics of a perfect square trinomial. Let's try number 2. So let's see if it meets the characteristics of a perfect square trinomial. So the square root of 25x squared is 5x. The square root of 4 is 2. 5x times 2 is 10x, and if we double that, we get 20x. So yes, this is a perfect square trinomial. And once again, plus plus in the factors are going to be, or in the trinomial will be plus plus in the factors. So 5x plus 2, 5x plus 2, this is our guess. And our guess needs to be followed by the check. So 5x times 5x is 25x squared. 5x times 2 plus 10x. 2 times 5x plus 10x. And then 2 times 2 plus 4. Add those like terms. There's our 20x. That's right there. So this is our answer. Our factors are 5x plus 2 times 5x plus 2. Of course, you can write that with the exponent, 5x plus 2 quantity squared. Either one of those are correct. Lastly, number 3. Number 3, the square root of 100x squared is 10x. The square root of 49y squared is 7y. And 10 times 7 is 140, or excuse me, 10 times 7 is 70, and 70 times 2 is our 140. But there's a negative right there. And we learned in the guess and check video that if it's minus plus, it will be minus minus in the factors. So 10x minus 7y times 10x minus 7y. This is our guess. Let's give our guess a quick check. Let's give our guess a quick check with the FOIL method. So this is going to be 10x times 10x is 100x squared. 10x times 7, negative 7y is negative 70xy. Negative 7y times 10x, negative 70xy. Negative 7y times negative 7y plus 49y squared. Combine those like terms. There's our 140xy, so our guess is confirmed. 10x minus 7y times itself. You can write it like that, both written twice, or you can say 10x minus 7y quantity squared. They're both correct. So, perfect square trinomial. Perfect square trinomial, we are done.